Good day, ladies and gents. My name is Lotabo, and welcome back to my revision series. Now I'm working on Sigma notations. Most interesting notations ever. Yeah, honestly, they are. So let's get to it. So Sigma notation is notation to express the summation of terms. So um, something like this. Summation of C up until n from I is equals to 1 to equals to nc, because it will be as follows. Let's say we had an example of I is equals to 1, 8 will be 8 plus 8 plus 8 plus 8. So it will be 4 plus 1 minus 1, so it's like sum 8 4 times. So it will be this. So basically, this is equals to 4 times 8, and which is 32. Another example being I is equals to 1, 7, which will be 7 times 8, which is 56. And then the other one will be 5. I is equals to 1, 9, which will be 5 times 9, which will be 45. So that's just the basics of it. Right, but we have other formulas in Sigma notations that are really important. So the first formula will be this. Okay, the second formula will be this. Let's see. Just say I. So this one will be n plus 1 over 2. This could be deduced from the summation of an arithmetic sequence, linear sequence. So if you have this, Sn is equals to n over 2, 2a plus n minus 1 d, where let's say the first term is 1 and common difference is 1, so we have Sn is equals to n over 2. First term is 1, so 2 times 1 is 2, plus our common difference is 1, so you have n minus 1. So you have Sn is equals to n over 2, n plus 1, which you have Sn is equals to n plus 1 all over 2. This could be deduced from that. Then the second formula that we have is this one, which is n plus 1, 2n plus 1 over 6. Now, one could prove this formula in two ways. One way is by induction, and the other way is using the telescoping method. Alright, so yeah, which one should we use? Let me think. So let's see the telescoping method. So then the telescoping method, we're gonna have something like this. So summation of 1 plus I all cubed minus I cubed. Right? And then let's first simplify everything. So the simplification of everything is going to be say plus say 1 here cubed minus 1. It's basically 2 cubed minus 1, then plus, and we have 2 plus 1, which is 3 cubed minus 2 cubed. Then we have plus 3 plus 1, which is 4 cubed minus 3 cubed. And we have plus dot the term before n, which is n minus 1. So we're gonna have n minus 1 plus 1, which is n cubed, right? Minus n minus 1 all cubed, and then have plus, then we're gonna have n, which is n plus 1 all cubed minus n cubed. So notice that the following terms result in 0. So this term and this term result in 0. This term and this term result in 0. So this term and this term will result in 0. And then this term and this term will result in 0. And this term and this term will result in 0. So what we will have is the following. You will have n plus 1 all cubed minus 1 cubed. So this is n I is equals to 1 plus I cubed minus I cubed. Right? So this is equals to the following: n plus 1 n squared plus 2n plus 1 minus 1, which is equals to n cubed. Let me plus 2n squared plus n squared plus 2n plus 1 minus 1. So it'll be n cubed plus 3n squared plus 3n. Right? So this is the first part. Then the second part is as follows. We'll have summation is I is equals to 1 plus I cubed minus I cubed. So this is equals to 1 plus I 1 plus 2I plus I squared minus I cubed. I is equals to 1. So then I have 1 plus 2I plus I squared plus I plus 2I squared plus I cubed minus I cubed. So I is equals to 1, and so we're gonna have something like this. I and I goes, and just do this. I goes, right? So we have 3I squared plus 3I plus 1. Right, so this is equals to n cubed plus 3n squared plus 3n. Right? So let's take the sigma inside. So we get 3 I is equals to 1 I squared plus 3 I is equals to 1 I plus I is equals to 1 1, which is equals to n cubed plus 3n squared plus 3n. So we've got 3 n I is equals to 1 I squared plus 3, this is n plus 1 all over 2 plus n is equals to n cubed plus 3n squared plus 3n. So 3 I is equals to 1 I squared should be equals to following should be equals to n cubed plus 3n squared minus 2n plus 2n, sorry, meant to say plus 2n minus 3n squared plus n all over 2. Right? So we have is 3 n I is equals to 1 I squared is equals to n cubed over 2 plus is 3 6 Okay, let me just erase that. It was, yeah, the device is correcting me a bit. Okay, so we have 2n cubed all over 2 plus 6n squared all over 2 plus 4n all over 2 minus 3n squared all over 2 minus 3n all over 2. So 3n I is equals to 1 I squared is equals to let me see, we have 2n cubed plus 3n squared plus n all over 2, right? So we have n 2n squared plus 3n plus 1 all over 2, right? So if I multiply the mother and the father, that's the first term and the last term, this expression, I get 2n squared. So which factors do I need to get 3n? Well, it's 2n multiplied by n, right? So we get n 2n squared plus 2n plus n plus 1, right? All over 2. So this is equals to n 2n n plus 1 n plus 1 2, which is n plus 1 2n plus 1 all over 2. So let's not forget to carry this one down, squared 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 squared. So multiply both sides by 1 over 3. What do I get? I get squared is equals to n plus 1 2n plus 1 all over 6. So that's proving it using the telescoping method. And then let's see by induction. Let us see by induction. Hey. Okay. Let's see by induction. So I'm gonna erase this now. So basically by induction, for once 1, we need to show that it holds for 1, right? So and right, I goes to 1, and then 1 squared, which is equals to 1. And then we're gonna have 1, 2 times 1 plus 1 over 6, which that is 1, 2, 3 over 6, which is 1. So it holds, right? 2, now assume it holds for k, where k is an element of integers, positive integers. So assuming it holds for k, we are going to have the following. So right, now prove that it holds. Prove it holds for k plus 1 in the term after k, right? Where k plus 1 is an element of positive integers. So let's prove that it holds for k plus 1. So we're gonna have 1 squared plus 4. Let's just say 1 plus 4 plus 9 plus k minus 1 all squared plus k all squared plus k plus 1 all squared, right? So this is equals to k plus 1, 2k plus 1 over 6 plus 6k plus 1 all squared all over 6, right? So what that is saying is the following. For to take out k plus 1 on both sides, and 1 over 6, we would get k, 2k plus 1 plus k plus 1. We have 1 over 6, k plus 1. And then now comes the distributing and factorizing part. So I have 2k squared plus k plus k plus 1. So all in all, okay, we left, there was 6, a 6 was missing, 6 and 6, right? So we have 1 over 6 k plus 1, 2k squared plus 7k plus 6. If I multiply the mother and the father, I get 12k squared. Right. The factors that form 6 is 4k, that form 7, meant to say, sorry. It's 4k and 3k when added together. So 1 over 6 k plus 1, 2k squared plus 4k plus 3k plus 6. So 1 over 6 k plus 1 will be thus equals to 2k k plus 2 plus 3k plus 2. So 1 over 6 k plus 1 will thus equals to k plus 2, 2k plus 3. Okay, set. Now, we're gonna have k plus 1. Please note the following. Then we're gonna have k plus 1 plus 1. Right? And we're gonna have 2k plus 1 plus 1. Wait. Okay. Gonna have 2 k plus 1 plus 1. This is all over 6. So therefore, it is 2 for all positive values of n. So that's the proof of that. Yeah, tedious, I know. Right. It works. And then our last equation is given by this. Okay, so that is what we have for our equations. Now we're about to do a few questions, and then we will be done. Done. Okay, so assume you're given the following. So this is examples. Example number 1 is find the following. Or evaluate the following. So evaluate this up until term 5, the 5th term until 5. So what we're going to do is expand, but we still can use the formula, which will get the same answer. So let's see. This is 3, 6, 10, 15. Right? And when we use the formula, which is n plus 1 all over 2, we get 5 plus 1 all over 2. We get 30 all over 2. We get 15. See, the formula also works. But if you don't trust it, go the long route. But sometimes it will take you time, a lot of time. When you're writing a test, it's not really ideal. So 6, 1 plus 6 plus 6 plus 6. So let me see. This is like this is 6, this is 12, this is 18, this is 24. Right, so this is 30, this is 30, so this is 60. So now we're using the formula. We're going to take the 6 to the side. We'll focus on this. So she's going to have 6 times n plus 1 all over 2, which is going to equal to 6, 4 plus 1 over 2, which is going to be 3 times 4 times 5, which is going to be 12 times 5, which is going to be 60. See, you get the same answer. Example number 3. You can pause the video and do it on your own. Do something like this. 5th I is equals to 1, 7i minus 3. So this is 7, right? So again 1 minus 3, 7, 2 minus 3, 7, 3 minus 3, 4 minus 3, 5 minus 3. This is 4. 14 minus 3 is 11. 21 minus 3 is 18. Yeah, it's 18. 28 minus 2 is 25, sorry. And 35 minus 3 is 32. So you have 15. We have maybe 30, 40, 43. 43 if I'm not mistaken. So you have 15 plus 43, it's 58, plus 32, it's 90. So that is what we have. But using the formula is going to be a lot easier than what we just did right now. It's going to be seven n I equals to 1 I minus I is equals to 1 3. What am I saying? It's n here on top. It's 5. So it's going to equal to 7 times. Let me just write the formula. 1 over 2 minus 5 times 3, which is going to be equals to 7, 5, 5 plus 1 over 2 minus 15, which is equals to 7, 5, 6 over 2 minus 15, which is equals to 13 divided by 2 is 15. So 15 times 7 minus 15. So we have 15, 7 minus 1. We should have 15, 6. We should have 90. And number 4, I 5, I is equals to 1, I squared plus 4I. This one I'm not going to do it in the long version, I'm just going to do it in the short version. So I'm going to have I is equals to 1 and I cubed plus 4I squared. So I'm going to have Okay. Squared, so I'm gonna have sorry, this is supposed to be a 5, then n is 5, it's 5, and so we're gonna have n squared, n plus 1 squared, 1 over 4. This is like the first formula squared. It's like this. All squared. It's the first formula squared, basically. And then here we have 4 n plus 1, 2n plus 1 all over 6. So we have 5 squared, 5 plus 1 squared all over 4, plus we have 2 times 5, 5 plus 1 times 2 times 5 plus 1 all over 3. So we have 25, we have times 36 all over 4 plus 10 times 6 times 10, 11 all over 3. Whew. Hey, it's sweating. Oh, it's interesting. So we have 25 times 9 plus 10 times 2 times 11, and then 25 times 9 is 225 plus 22 times 10, which is 220. So our answer will equals to 445. Okay, let's do number 5. Just something like this. 9i is equals to 1. I minus 1 squared, which is equals to 9. I is equals to 1. I squared minus 2i plus 1. So this is like this. So we're gonna have 9i 1i squared minus 2 9i is equals to 1i plus 9i is equals to 1. Okay, my eyes look like my ones. Let me just make them a bit clear. I want this. Oh, so n plus 1, 2n plus 1 all over 6 minus, just writing the formula, so be careful, just not expressing it now. Plus n, right? Where our n is as follows. N is 9. 9 plus 1. 2, 9 plus 2 times 9 plus 1, because it's gonna be confusing if I say 2, 9. What? It's not 29. It's not 29. It's 2 times. Minus 9. 9 plus 1 plus 9. So it'll be 9, 10. This is 18, 19. By 6 minus, this is 10 times 9 minus 90 plus 9. Before we minus, let's just see if this one will make our job a bit easier. So we have a 3 that we are giving away here, we have a 5 that we are giving away, we have 19 here. We have minus 90 plus 9. So we have a 15 times 19, which is 285. Calculator work. Maybe, but I could do it manually. It's not that hard. Plus 9. So now we have 195 plus 9, which we have 204. So this is our final solution. Solution. Looks good, doesn't it? Looks attractive. I wanna date it. Should we do another question? I think we should. I'm seeing an interesting one. Very interesting question. So this is number 6. See, the interesting question is coming last. This is not the interesting question. I cubed minus 4i squared plus 5i plus 7. Right, so this is what we have. And then we have the following: 12. I is equals to 1, I cubed. Minus 4 to 12, starting from 1, I squared. Plus 5 to 12, starting from 1, I. Plus 7 to 12, starting from 1, 1. So this is wait, let me think about this. It's n squared, n plus 1 squared all over 4. Almost said 2. So I'm just writing the formula again. So n plus 1, 2n plus 1 all over 6. Plus 7n, where our n is 12. It's gonna be hard multiplying 12. So 12 squared is 144, right? And 13 squared is 169. 169. If I'm not mistaken. Right? Yeah, but I'm not. Should have just worked on dividing, it would have been easier if I did that. Okay, let's do this. Say 12 times 12, let's just say that, over 4. I think that's a bit easier for me to divide these things. Then we're gonna have 2 Then we're gonna have times 12. We're gonna have times 13. I'm gonna have 12 times 2 is 24 plus 1 is 25 all over 6 plus 7 times 12. So here we're gonna get 3 times 12 times 169. There's no division now, it's erased. This was supposed to be 3 minus 2 times 4 times 13 is 25 plus 7 times 12. Oh, that one is quite interesting. I think I'm gonna need a calculator here. I am going to need a calculator. This is a bit too much. A bit too much. A bit too much. There's one term missing, right? Yeah, it is. Oh, so plus 5 n plus 1 all over 2 plus 5 12 13 all over 2 plus 5 times 6 times 30. Yeah, so we have all of this. So we have 3 times 12 times 169. That's 184. No. That's impossible. That's impossible. It's 6084. Imagine if it was on ill. It would have been very funny. Let's have been that number. So 169 doesn't do anything, but times 25 F2600. There are common factors that I could take out and know that, but I didn't. Why? I don't know. 84 plus 5 times 6 times 13, that's 390. So we have 6084 minus 2600 plus 84 plus 390. So it's supposed to be 3958. So this one was unnecessarily not cool. This is a calculator question, and the module that I'm doing, I'm not supposed to be using any calculator, so we have this now. So now we're starting from I is equals to 4, ending at 24 for I cubed. This one is an interesting question, right? Yeah, it really is. Okay. So, I'm going to do it like this. Let's start from I is equals to 1. I cubed. And subtract the other 3 that's remaining here. I cubed. Right? Let me see. 24 minus 4 plus 1 equals to 21. Okay. Yeah. It's okay. It's right. Then to go to n squared n plus 1 all squared divided by 4 minus n squared n plus 1 all squared divided by 4. Remember, these ends are not the same. The ends are not the same. So I'm going to call it n2 and I'm going to call it n1. So n1 is the larger number, which is 24 squared. Wow, that's a large number. Then we have 24 plus 1, which is 25 squared. All over 4. Wow. Okay, let me just do this. 24, 25 over 4 all squared, which is equals to 6 times 25 minus 3 all squared over 4 all squared divided by 4, which is 9 times 4. So you have 36 inside. Right? So 25 times 6, let me see, times 4, it's going to be 100, and times 6 is 150, is it? Oh, this is still squared. Yeah, it's 150 all squared, which is at 36. Oh, okay, there's something missing. Okay, see something. This is supposed to be 2. This is now 12. Yeah, now it makes sense. So 12 times 25 is 300 all squared. 90,000 minus 36. Yeah. It's 89964. So that is our solution. Thank you guys for watching. Make sure to like and subscribe so a lot more people could be educated by my videos. Peace. Enjoy your day.